please. Woo-hoo! Let's do this. All right. So, warm up. Go ahead and draw on your piece of paper a nice little 5x5 grid. Keep in mind that I would like you to label the 1, 2, 3, 4, 5. Go ahead and label it all the way around. And then after you do that, I would like you to go ahead and just graph each of these coordinates. 5. -5. Awesome. Take a minute, pause it, graph it, and let's move on. And here we go. I'm going to use bright blue. So A is 2, 0, which means I go over 1, 2 on the X, 0 on the Y, right there. B is -2, -4, so I'm going to go back 1, 2 on the X and down 1, 2, 3, 4 on the Y. C is 3, 2, 1, 2, 3, up 1, 2. Remember, positive goes right in the X and up in the Y. Negative goes left in the X and down in the Y. Now we're on to, and what was this, by the way? Let's see, this was a, oh no, we don't need to label it. You guys know what we're doing. Let's see, we're A, B, C, D is 4, -2, so 1, 2, 3, 4, and then down 2. And E is -1, up 1, 2, 3, boom. There we go. Hopefully your graph looks like that. We want to make sure we know how to graph points. It's important when you're graphing, right? Let's move on. Today we're talking about intercepts of graph. It's that point where it crosses the X and the Y axis, and more specifically what that means to us. Let me move myself out of the way. It says a water park sells annual memberships for $79 for a single day passes for $8. The revenue from the admissions to the water park for a single day pass was $31,600. This is shown by the graph down here. Okay, we see that? You can find the X and Y intercepts of the graph to determine the number of annual memberships sold if no single day passes were sold, and the number of single day passes sold if no annual memberships were sold, respectively. So we see that there's a little continuum here showing us what needs to be done to get that $31,600, right? So if no passes were sold whatsoever, then we see right here approximately, or no annual membership sold, then it would take approximately 4,000 single day passes sold to get that $31,600. If, on the other hand, only annual memberships are sold, then it's going to take approximately 400 annual memberships. So selling an annual membership, they have to sell way less of those to get to that total. They got to sell way more of the single day passes. Makes sense. One's $8, one's $79. But there's probably a combination thereof, or clearly there was. So that's what these are telling us right here. Again, oh, that y-intercept is exactly 4,000. So we know that it takes 4,000 single day passes sold to bring that total, or again, the 400 exactly to bring to that total. Awesome. So we're talking about intercepts today. Intercepts are pretty important deals for us. And we're going to get into a little vocabulary, which is funny because this is missing one vocabulary word, which I will add. But we have the x-intercept, positive, root, and 0. Here's what I'm going to tell you. The x-intercept is the x-coordinate of a point where the graph crosses the x-axis. It is that point, some value of x. Y is always 0 on the x-axis, okay? What they forgot to say was y-intercept. I have no clue why that's not in here. I know we're focused more on the x today. Maybe they'll hit that more on another day. But I want you to have that right off the bat. It's the same thing, except it says the y-coordinate of a point where a graph crosses the y-axis. So just copy the same definition, but put y instead of x. And a y-intercept is always at the point 0, y. In fact, you want to get some credit on a test, you may not know what that y or x value is, but if you at least put these parentheses set up just like this, at least you know what a y and an x-intercept is, even if you can't find it. Now, positive. What's a positive? When we're talking about graphs, we're talking about where the graph of the function lies above the x-axis. So, for example, I'm going to give you an example. I'm going to include both the positive and the negative. Let's do just this graph right here. And I'm going to get a different color. Let's use yellow to start off with. The positive is where that graph is positive. The negative is where that graph is below the x-axis. So the positive is above the x-axis, the negative is below the x-axis, okay? So it's where the graph of the function lies above the x-axis is the positive. Again, it doesn't say negative, but it's the opposite. A root is a solution of an equation. Want to know what else a root is? A root is an x-intercept. How about that? A 0 is an x. This also is an x-intercept. It is an x-intercept of the graph of a function, a value for which f of x equals 0. Remember, f of x is just the function notation for saying y equals 0. Remember, what is the value of every y at every x-intercept? 0. So when f of x equals 0, that gives us our x-intercept, which is also our root. One of the roots of a function, okay? Or of a solution of an equation. Awesome. Go ahead and write these down. Pause me if you need to. Let's go. Okay, it says the x-intercepts of graphs are points where the graph intersects the x-axis. Those are also the roots or the zeros. And what are the roots, zeros, and x-intercepts? We see right here, -4, -2, and I don't know what that one is right there. That looks at about, see if that's 2, that's 1. Oh my goodness. So that would put this at like 0.25 or 0.3 or something like that. So it's just a decimal. What are the y-intercepts? Well, that's where it crosses the y-axis, which is clearly right here. Which that would be the point, what? 0, -3? Again, the x value is always 0 at a y-intercept, and the y value is always 0 at an x-intercept. Now the positives, that's everywhere it's above the x-axis, so we see the positives are up here, and the negatives are the opposite, they're down there, okay? So, can the graph of a function have more than one y-intercept? I want to talk to you guys about that, so let's talk about this. If this were to have more than one y-intercept, that means at some point up here, it swings back around. Here's the problem with that. If it swings back around, it's going to fail the vertical line test, isn't it? So no, a function cannot have more than one y-intercept. A function can have tons of x-intercepts, but it can only have one y-intercept. You want to put that in now. In your notes, only one y-intercept. All right. Moving on up to east side. Hey, it's just a little loading music. You know, in video games, whenever you go in an elevator in between levels and it feels like that elevator's going slow, like if you ever played Mass Effect back in the day, those, especially the first game, the elevator was super slow. Or if you ever do that in games, or you go to this scene where all of a sudden it zooms in on your character and he's slowly crawling through something, you know why that's done? That's done so in the background, the game can be loading in. It's called a loading screen. It's basically an interactive loading screen. So in the background, the game's loading in all the textures and everything coming on the other side of that tunnel or outside of that elevator, and they don't want you to see a loading screen, so they hide it with that. Interesting facts. Okay, intercepts of the graph of a linear function. So this is a linear function. We know that because this is a straight line, thus linear. Use the graph of the function to determine the key features. So drag the coordinates of the x-intercept and y-intercepts of the graph to the appropriate boxes. Let's see right here. We see our x-intercept is on the x-axis. It's right here, which looks to be -1, -2. So that's going to be at x equals -2 and y equals 0. And remember, I can go ahead and plug that 0 in for the x value on the y-intercept. It's always 0 at the y on the x-intercept, always 0 at the x on the y-intercept. And where does it intercept the y? It looks to be right here, which is 1, 2, 3, +4. Boosh. Let's check that answer. Yeah. Now let's talk about the negatives. And I want to draw a little bit here, negative and positive. Where is this function positive? Well, it's clearly positive up here. And what is the value of x? That's negative 2. So for x is greater than negative 2, it's positive. And look at that. For x is less than negative 2, it's negative. Okay, so let's find out where that's set over here. Positive, so we want it positive for x is greater than negative 2. Oh, I see it right here. We want it negative for x is less than negative 2. Negative for x is less than negative 2. Boom, we already found it. It's A. Let's check that answer, and boom, right there, we got it. Oh, wait, if you ever log into these slides online, underneath, there's a lot of times a need help, which gives you a little video access to show you how to do this. I will warn you. Boringest voices ever, but they actually have some good math knowledge, so there's a little resource for you. All right, let's go on. I like coffee. Okay, right here, we're not even going to push on the buttons. Let's figure this out ourselves. Where are the x-intercepts? Well, the x-intercepts are right here at negative 4 and over here at positive 3. Those are my x-intercepts. Where's my y-intercept? My y-intercept is down here at negative 4, negative 8. Looks to be right about negative 12. And then it says, where is it positive? Well, it is positive where it's above the x-axis, but notice that's in two different areas. So if I were to write this down, I'd say it's positive, that's at 3, where x is greater than 3. You know what, I'm going to label this intercept right here. You ready? This intercept is 3, 0. And this x-intercept is negative 4, 0. I'm doing this on purpose. I want to show you all something. And where is it positive over here? Well, it's when it's to the left, so less than negative 4. So x is less than negative 4. Notice that this uses my intercepts or my roots or my zeros of the equation. Okay? So our roots help us find where we can determine where it's going to be positive or negative. And now what do I see right here? I see the negative part of this. Boom. Is the in between. And here's where I'm just going to show you what it is. So that's where x is both less than 3, and yet x is also greater than negative 4. So see how it's in between there? It's less than 3, but greater than negative 4. So good stuff, good stuff, good stuff. All right, I'm going to erase this. Mark it as you can. Ready, set. Moving on. I like graphing. I always have. All right, so it says the graph shows the population Y of birds X years after they were brought to an endangered species park. Use the graph to estimate the X and Y intercepts of the function. So the X-intercept right here is number of birds. Let's see, these are going up 10, 20, 30, 40, 50. X-intercept, or that's the Y-intercept, excuse me, this is the Y-axis, duh. So the y-intercept I'm going to put in first is at 50, and my x-intercept is time in years. It appears to be 8 years. Look at that, we're right. So what is the meaning of the x and y-intercepts in the context of this situation? Well, I'm going to tell you guys. So it tells me, the y-intercept tells me where we're starting at. It says at year 0, the sanctuary starts with about 8 what? 8 total birds. Or excuse me, not 8. I was looking at my x-intercept. 50 total birds. Then what does the y-intercept tells us? And this is, I should probably write that down. X Intercept. It is a lot easier to type than write with my mouse, so that's why I'm doing this. What does the y-intercept tell us? Well, the y-intercept says, hey, after 8 years, there are 0 birds left in the sanctuary. And we don't know why. Maybe they raised them up, released them into the wild. I hope they didn't all die. That'd be kind of sad into the story. But that's what we're talking about. So that is the context of these intercepts. They tell us more than just numbers. They're telling us a situation that's occurred, okay? And we can even see from this graph what happens. The bird population goes down at first, but then all of a sudden it shoots up, and it peaks over here just a little bit above 70, like 71 birds, and then it slowly declines. And again, we don't know why. Maybe they were, and it's not really that much slower of a decline. It's over a few years. I guess it's kind of slow. So is it that they're slowly releasing them? Maybe the sanctuary is shutting down. They're slowly releasing them elsewhere. We don't know. But something happened to bring that population to 0 at 8 years, okay? All right. Again, need help videos right here about how to interpret graphs. Those are there. Okay, and this will be our last example for the day to go through. And we're just really focusing on intercepts. Now we're going to talk about intercepts from a table. Again, remember your x-intercept, right? Is always at some value of x, 0 for y. So if I'm looking at a table to find the x-intercept, I am looking where y is 0. So where's the y 0? Down here. So this is my x-intercept. If I'm talking y-intercept, it's where x is 0 and y is whatever value comes with it. So remember, I'm looking for where x is 0, which is up at the top. That's convenient, okay? So here's what I'm looking for. Make sure you have this information marked down. I'm going to erase it so I can actually do some stuff and interact down here, but let's look. Okay, so part A says, let's identify the intercept. So where's the x-intercept at? The x-intercept is where y is 0, x is 40. Where's the y-intercept? It's where x is 0 and y is 80. We did it. Let's look at part B. Describe what the x-intercept means. Okay, it's where y is 0. It's the number of bags. What does it say? Grayson is creating 2-ounce giveaway bags from a larger box of candy. So we've got this box of candy. We're making little 2-ounce bags from it, right? Packing little Halloween bags. The table shows the function relating the weight of the candy remaining in the box Y and the number of bags Grayson has created. Okay? So this x-intercept tells me if I make 40 bags, I have 0 ounces of candy left, which makes sense. If there are 2 ounces a bag, does it tell us how much candy is in the box? No, it doesn't. But kind of does, right? Because the y-intercept tells us that, but we'll get to that. So it tells me if I make 40 bags, there are 0 ounces left in the box. So the x-intercept, after creating 40 bags, there will be no candy left in the box. Boom. Let's go to part C. Probably what does the y-intercept mean? Well, it's where x equals 0. So if I've made 0 bags of candy, how many total ounces do I have in the box? I have 80 ounces. So that's telling me how many the box started out with. The box initially contained 80 ounces of candy. Boosh, right there. Again, we are just interpreting what the intercepts mean. All right. Well, it's time for you to get some work done. With that said, peace out.